Offshore wind and marine mammals, balancing progress and protection. Around the world, the effects of climate change, such as warming oceans, shifting currents, declining sea ice, and ocean acidification, are reshaping marine ecosystems. These pressures are driving a growing demand for sustainable and renewable energy solutions. As we move away from fossil fuels, renewable technologies are expanding quickly, but their ecological impacts require careful evaluation. One major area where this tension plays out is offshore wind development, which is increasingly built in marine habitats that support a wide diversity of marine mammals. Renewable sources like hydro, solar, geothermal, and wind offer substantial reductions in carbon emissions, but they also have ecological costs. Large-scale installations require land use, resource extraction, and infrastructure development, which can disrupt wildlife and ecosystem function. So while renewables are essential, it's equally important to understand the trade-offs associated with them. Offshore wind is growing rapidly because it avoids some of the limitations of land-based wind. However, the marine environment is already heavily affected by human activities such as harvesting, bycatch, pollution, and habitat modification. These historical pressures set an essential context for understanding how new activities, like offshore wind development, might add additional stressors. Because of this, environmental assessments play a key role in identifying and mitigating risks before construction begins. Offshore wind developments benefit from stronger and more consistent wind resources and the ability to operate at large scales far away from populated areas. But the areas most suitable for turbines often overlap with important habitats used by marine mammals for feeding, breeding, and migration. This creates a challenge. How do we expand low-carbon energy without compromising marine ecosystem health? One of the primary concerns is underwater noise. Marine mammals rely on sound far more than terrestrial animals because light attenuates quickly underwater. Odontocetes use echolocation to hunt and navigate, mysticetes communicate across long distances, and pinnipeds use sound in both air and water for social interactions. Because sound is their dominant sense, even moderate noise increases can disrupt essential behaviors. The loudest noise occurs during construction, particularly during pile driving. These impulsive sounds travel long distances and can be powerful enough to cause auditory injury. They also mask communication calls, interfere with foraging or mating, and can displace animals from their habitats. In some cases, entire communities may temporarily abandon a region during construction. Once turbines are operating, they produce lower intensity but continuous noise through mechanical and hydrodynamic processes. Even though these sounds are quieter, they operate constantly and can affect animals over long periods. Chronic disturbance can influence energy budgets, communication ranges, and stress levels, especially when multiple turbines operate in clusters. Although noise is one of the most widely discussed impacts, major knowledge gaps remain. There are still few studies that directly measure behavioral changes around wind farms and almost no long-term datasets. This means precautionary approaches and continuous monitoring are necessary as development expands. Another concern is habitat alteration. Marine mammal habitats are defined by oceanographic features like temperature gradients, prey distributions, and acoustic conditions. Turbine foundations, anchors, and cables physically alter the seafloor and may block access to historically used areas. When many turbines are installed close together, they can fragment what was once a continuous habitat. Construction activities like dredging and pile driving disturb sediments, harming benthic communities that support fish populations. Because many marine mammals rely on these fish species, prey depletion can indirectly reduce foraging opportunities. These cascading effects link turbine installation to wider ecological changes. Beyond physical habitat changes, marine mammals may avoid noisy or disturbed areas. This avoidance behavior can lead to energy deficits, especially for capital breeders like seals and baleen whales that depend on limited feeding periods. In some cases, individuals may abandon important feeding or calving grounds altogether. To address these challenges, better research and management strategies are essential. New risk-based frameworks now evaluate exposure and behavioral outcomes, not just raw noise levels. Spatial modeling also helps identify regions where species may be particularly vulnerable due to overlap with proposed developments. However, many gaps remain. We need species-specific response data, research across all life stages, and long-term monitoring to inform effective mitigation. Offshore wind energy is crucial in reducing greenhouse gas emissions and transitioning away from fossil fuels. But to achieve truly sustainable outcomes, we must understand and mitigate the effects of these developments on marine mammals. Offshore wind brings both benefits and risks, and environmental assessments provide a pathway to balance climate progress with marine conservation. Continued research, careful planning, and ecosystem-based management are essential to ensure that renewable energy expansion supports the health of our oceans. Here are the references for this presentation. Thank you for watching.